Meet Dave. Dave works hard, lives honestly, and drives his truck for long hours to deliver goods for high-profile large freight corporations. He is an integral part of Australia's supply chain distribution network. However, his work does not return this favour. Many truck drivers, just like Dave, suffer from fatigue, exhaustion, and low job satisfaction, leading to a poor quality of life and an increased risk of fatigue-related deaths on the road. This, in turn, has a significant impact on large freight companies, leading to low company image and delays in goods distribution. Australia, being such a vast and scarcely populated country, relies heavily on a strong freight distribution network, allowing for the transfer of essential goods and services across our major cities and manufacturing hubs. Over 56,000 companies currently exist in Australia directly related to freight distribution, making up a share of over $51 billion of the economy. This large and diverse market remains open for innovation in design to fix the many issues which are related to driver satisfaction and quality of life. In a survey of over 1,000 truck drivers around Australia, the shocking results show the desperate need for better standards in road transport, for workers, for families, and for the greater society. One truck driver answered, "The whole industry needs to be overhauled. I work anywhere from 12 to 17 hours a day, up to 6 days a week. To put that into perspective, I'm fatigued every day I go to work, but I'm still expected to turn up and do the job." This notion is further developed in a study conducted by the National Transport Insurance Company, which found that in 2019, 53 truck drivers passed away on Australian roads, with the largest single factor being fatigue, sitting at 34% of these deaths. These alarming accounts of truck driver experiences demonstrates the clear and urgent need for a new range of modules to increase driver quality of life and reduce fatigue and tiredness on our roads.
Our solution to Dave's dilemma is a new state-of-the-art system composed of 3 interconnected energy-centered modules as shown on the screen. These modules will be a tracking solar panel, a lithium-ion battery, and our main product, the Wayback Chair. So what is our product and how does it help Dave? Put simply, the Wayback Chair is an innovative truck seat with improved sitting and sleeping positions integrated within it. Our seat includes various features including an increased range of motion and a larger expandable surface area compared in size to a single bed. This is accomplished through a series of DC motors which recline the main seat frame and fold out the accessory comfort panels, allowing for better sleeping and relaxing positions that gives Dave the much needed sleep he needs. Additionally, the seat provides greater ergonomic support through an air expanding lumbar support system, which can be adjusted for personal comfort. Sitting for hours on end in a conventional truck seat causes reduced circulation to the lower body, leading to numbness and irritation. By allowing adjustable ergonomic seating positions, we can eliminate these issues and promote a healthier seated position, which will improve mental and physical well-being whilst positively impacting employee satisfaction. Now, where do we obtain the energy that powers our product? After all, it's not like it appears out of thin air. In terms of energy accumulation, we've combined sensors, photovoltaics, and a mechanical design to provide an efficient energy harvesting system through a tracking solar panel. This system includes a customizable number of 12-volt, 40-watt solar panels mounted on an automated system, which allows it to capture and convert optimal levels of sunlight. By using a tri-legged design involving folding scissor mechanisms and linear actuators, the solar panel is capable of orienting itself along a dual axis, meaning it can tilt towards any direction to a certain degree. When exposed to sunlight, the angle at which the sun's rays strike the surface of the solar panel determine how efficiently light converts into electricity. Ideally, the light should strike perpendicularly to the surface. Through the use of sensors, the solar panels will automatically orient itself towards an optimal angle which allows it for efficient energy harvesting. Compared to static panels, tracking solar panels can produce up to 45% more energy. Once energy has been accumulated by the solar panel, it gets transferred as DC power and stored into a 120 ampere-hour lithium battery integrated under the Wayback Chair. The energy in the battery is then transferred to 3 separate places: back to the solar panel, the Wayback Chair, and the truck's battery. The solar panel receives energy for the linear actuators in its legs, allowing it to move around and angle itself. The Wayback Chair receives energy for its DC servo motors, allowing its features to function. And finally, to ensure integration with the vehicle, the device can backpower the truck's 12-volt lead-acid battery when energy accumulation is greater than usage requirements. All energy transfers are accomplished through high-efficiency copper wiring.
Our design features a number of fasteners, primarily located in the adjustable frame for the solar panels. The three legs of the adjustable solar panel system are connected to the truck's exterior through the use of pin joints, allowing the member to rotate. These pin joints will be held in place by 4mm steel pins, securely providing connection points for the solar panel to attach to the frame and for the frame to attach to the truck's roof. To be conservative, the solar panels and adjustable frame are estimated to have a weight of 25 kilos, allowing these pin connections to have a factor of safety of 38. Having such a large margin of safety allows the design to withstand unexpected forces, such as aerodynamic drag and gusts of wind blowing from various angles. As these factors cannot be accurately calculated or measured, the extra security of having a large factor of safety is highly beneficial to ensure no unexpected failures occur. Each of these pin joints are bolted to the roof of the truck using 4 8mm bolts to ensure the solar panel frame remains attached to the truck and does not loosen while driving. These bolts will primarily experience a shear force due to the effect of drag while driving, but also a tensile force that clamps the pin joint to the roof of the truck. Additionally, sliding connections are used throughout the design to allow a degree of translational freedom, greatly improving the range of motion of the solar panels. These consist of a sliding pin constrained within a slotted member. In our design, there will be two systems that consume electrical energy, namely the linear actuators that control the solar panel orientation, and the DC servo motors that control the position of the backrest, leg rest, armrests, and auxiliary panels. Our power calculations were based on the assumption that the DC servo motors are operating continuously at their peak load for a period of 12 hours overnight without solar charging. To have sufficient power, we're using a 12-volt 40-watt solar panel to charge the 120 amp-hour lithium-ion battery. The greatest load would be placed on the motors when the folding panels are parallel to the truck floor. And given that the backrest and leg rest each weigh 15 kilos and the auxiliary and armrest panels weigh 5 kilos each, we can calculate the torque and thus power needed to fold the panels into a perpendicular orientation. Allowing 10 seconds for the transition between horizontal and vertical, we can determine an angular velocity. Multiplying the velocity by the torque gives us an estimate for the peak power draw for each motor. Now, factoring in the number of parallel motors gives a peak power draw of approximately 23.11 watts. Dividing this by the rated 12 volts of the motor will then give a current draw of 1.93 amps. The 40-watt solar panel will provide sufficient energy to power both the linear actuators and the DC servo motors under these conditions. Additionally, we can use the current draw to estimate the battery capacity. With a 120 amp-hour battery and a current draw of 1.93 amps, we can expect the battery to last 62 hours. This is sufficient for 5 days of operation, even assuming every motor is continuously running overnight for 12 hours without battery charging.
Most truck seats on the market already offer the ability to recline. However, these designs are not effective for getting a good quality sleep and can be detrimental to the long-term health of truck drivers. Although newer seats have functions such as air suspensions, inbuilt air conditioning, and automatic leveling systems, these features do not have any impact on the sleep quality of truck drivers. They are simply gimmicks that make life easier and more bearable while driving. On the other hand, our design serves to improve the overall lifestyle of a truck driver, incorporating all these features plus the ability to give the drivers a better sleep, which is simply unattainable using conventional seats. The ability for a driver's seat to expand into a full-size single bed has not been achieved by any product on the market so far, giving our design a strong competitive edge. The entire module can be easily retrofitted into existing vehicles on the market, with solar panels and seats being able to customize to specific space requirements. In future, we aim to work alongside large manufacturers such as Isuzu, Scania, and Mack to ensure that features can be optioned onto new truck models and delivered to companies already integrated into the design. As some long-distance trucks already have a form of sleeper cabins, the introduction of seat module allows for freeing up of such space for use in other circumstances such as work, leisure, and cooking. Our system includes solar panel, 3 linear actuators, 7 DC servo motors, lithium-ion battery, truck seats, fasteners, wiring, and materials used to machine other parts. Overall, the total price comes to $2,800, which is just over $1,300, greater than the common price of a high-end conventional truck seat with air suspension. As we have demonstrated today, that there is a clear and a desperate need for a product that satisfies the quality of life point discussed earlier. Such a product would make truck drivers happier, increase efficiency of supply chain distribution networks, and drive down threats related to fatigue in one of the most dangerous jobs in the world. The story of Dave may be just an example, but he represents the tragic plight of truck drivers all around Australia and the world.